So I first drew a picture of what was going to be happening. So you have ball A on this side and ball B on this side, and since they're both negatively charged, they're going to move in opposite directions. And I drew an LOL graph of what was going to be happening. So before they're released from a rest, you have all of their energy and potential energy and none in kinetic because it's starting from a rest. In the system is bead A and bead B. And then after they're released, when it reaches its maximum speed, all of the initial potential energy is going to be converted into kinetic energy. So we know that afterwards there's going to be no potential energy left and all of it's going to be kinetic energy. So for the equation of conservation of energy, you have the work external, which is none, plus the potential energy initial plus the kinetic energy initial equals potential energy final plus the kinetic energy final. So you know that kinetic energy initial and potential energy final are both going to be 0. So that leaves you with potential energy initial is equal to kinetic energy final. So there's going to be 2 equations because there are 2 different balls. You have beads, you have equation 1 and equation 2. And we know that potential energy is computed by K, Q1, Q2 over R. So then you have Q of bead A and Q of bead B. So the potential energy is going to be the same for each. So then I found out the potential energy of the system initially. So that's K, Q1, Q2 over R. And then I used that to find the velocity for equations 1 and 2, which is just the square root of 2 times the potential energy initial over the mass of the bead. So for bead A, it's going to be 0.0224 meters per second, and for bead B, it's going to be 0.0173. And these values make sense because the beads are heavy and their accelerations away from each other are going to be smaller. Also, the velocity of bead A is going to be larger than the velocity of bead B because A has a smaller charge.